Hey everybody, welcome back to Young Engineers of Today. Hey Jasper. Um, we're going to continue with uh, the Sensat, obviously. For those of you who are still using the emulator, or who are using the emulator like me, there it is. Hey Cademan. You know, it's really neato to see you. Um, but as expected, you were really excited to hear that. Okay, well, so yeah, we're going to continue with the Sensat. We're going to do some more stuff. Today is going to be more of a, we're actually going to get into the orientation of the Sensat and things like that, which I believe is going to be a little bit more difficult to emulate, if I remember correctly. But we'll figure it out anyway. We'll at least discuss the code and stuff like that, and get familiar with it so that you guys know why we're doing what we're doing, even though I can't explicitly show you easily. You guys, if I remember correctly, will at least do some kind of game with the Sensat. I don't remember if it's going to be Tetris off the top of my head, but it will be something. So we will, as helpful as that is. So we will, yeah. Well, the Sensat has buttons on it. At least I thought it had buttons on it. All right, well, I could be wrong. Anyway, oh, it has a joystick. Okay. You're totally right, it does. Derp-a-doo. Okay, but yes, so we'll continue with that today. If I am understanding correctly, this was the last slide that you guys left off on. Let me move this out of the way so I can delete that to make this easier to read. Where you went over temperature, pressure, and humidity with the Sensat, and it read it and provided you with some information on that, and it was pretty cool, and you know that was that. But what we're going to do is we're going to continue on that, and we're actually going to expand upon that and also work a little bit with orientation. So let's go ahead and get started. So yeah, you guys set up a thing that allowed the Sensat to read the ambient temperature, pressure, and humidity uh, in order to put it out to a display and tell you what the environment was around the Sensat. Obviously, not necessarily outside, but certainly inside your room or wherever you're working with the Sensat. It gave you an idea of what the environment was like. So now, um, because the whole idea behind this is the Sensat can be used in space. So we can prettify this by using some color to let the astronauts know whether the conditions are within sensible ranges. So according to some online documentation, this is the ESA, which has a presence on the space station as well. Actually, look at that. Okay, yeah. So this is stuff that's on the ISS as of February 2010. It's certainly expanded since then, but it's still the environment conditions are relevant. So if we see the ISS tries to maintain these conditions, they want to do 18.3 to 26.7 degrees Celsius, which is pretty cool to decently comfortable. Pressure 979 to 1,000 millibars, and humidity around 60%. So relatively comfortable conditions. If we were to do pressure and humidity at sea level, just with some Googling, 1,013 millibars of pressure, average sea level pressure. And we're not going to get humidity, actually. Humidity varies wildly, but 60% is is nice. It's not dry. It's actually less dry than in an airplane. Or. But yeah, it looks like they try to get the pressure right around sea level, the temperature in a comfortable range, and the humidity in a comfortable range. So it's actually it's more comfortable to live in the ISS than it is to fly in an airplane. Uh, Obviously, you know, the ISS can't do all the things that an airplane can, but regardless, it's in space and it manages to be a little bit more comfortable of an atmosphere. Space. So you could, theoretically speaking, use an if statement in your code to check these conditions and set a background color for the scroll. So if the temperature is or the temperature is inside of the acceptable range, space is cooler than airplanes, as in like it's more awesome or it's colder. Yeah. No, I definitely agree with you there. Well, I'm glad you said, Cademan. Space isn't necessarily cold nor hot. It's both, kind of ish. It's actually kind of hard to say just because there's no atmosphere in space. Obviously, it's a vacuum. So it's actually really terrible at wicking off or distributing heat. So radiators and things like that don't work nearly as well in space for obvious reasons because the heat has nowhere to go. um, but you could be in the sun and you could overheat. Say you're just floating in a spacesuit that has no temperature control. You could be in the sun and overheating, or you could be in the shadow and being very cold. It's both, but it's not strictly speaking cold out in space. It's just there's no temperature regulation, so it can be cold. Yeah, space is super incredibly hostile to human life. We'll try and keep it on track today, Caveman. But I appreciate the input. No, we're still going to try and make it through as much as we can today. Maybe at the end of the class. I know. I'm sorry. If you still really want to say it, you can throw it into the question box, and then maybe you can make a comment on it afterwards. But let's try and get through as much of this code as possible. So, yeah, if the temperature exists within a range, we'll say that the background is green. Otherwise, we'll make the background an angry red, and that will be a nice visual indicator that something's wrong. And of course, 5. Who knows? So let's update our program real quick and um, add that if statement in there. Get rid of that. Move this upwards. So I'm gonna type this program in from scratch, just so that we can go over it again as a nice little review. But if you have the program already, you can go ahead and open up your what is it called? Environment.py and get make some improvements to it. So obviously we're going to have from sensehat import sensehat. We got to make sure we import our sensehat library. Then we're going to create a sense variable, which is a sensehat class. It's an instance of a sensehat class. And a class is just simply a collection of variables and behaviors that sort of model a an object. You can make a class out of a car and stuff. And we'll get more into classes later. Yeah, that's true. Oh, yeah, definitely. Let me zoom in on this. Boom. I'll zoom a little bit out so I can see a little bit easier. But there we go. How's that look? And yeah, so that's true. That's true, Caveman. But again, it's yes, it's cold. Just because cold can be the absence of energy. Yeah, but yeah, gamma radiation and neutron radiation, alpha and beta particles and things like that. Um, those will definitely not be good for your health, and those can generate heat as well because those are energetic particles. So while true, so we're going to have a forever loop talking about our that dictates the flow of our program. So everything's going to be running inside of our forever loop, so that our sense hat will always be recording the temperature, pressure, and humidity and reporting it back to us. And T is going to be sense.get temperature. P is going to be sense.get pressure. And H is going to be sense.get humidity. So we've got get temperature, pressure, and humidity, and we're going to put them into temperature, pressure, and humidity variables respectively. Hawking radiation. Yeah, the stuff that comes out of black holes. So T equals round T1. P equals, no, it's definitely not. Round P1. Oops. And H equals round H1. So what exactly is going on here? Well, all these are doing, round is a function that just rounds to the nearest whatever. In this case, we're telling it to round to the nearest whole digit. So we're taking the temperature, which is just going to, or I believe it's one decimal place. Anyway, we're taking the temperature, which is going to be if the sense hat reads it, a lot of times it doesn't provide fixing on it. So you could get a temperature of, you know, 18.3964328. And well, that's very precise. That's too precise. Like that's more information than you need, and it can be hard to read and really kind of make things more difficult. So what we do is we round it to a useful amount of decimal places for us, so that it's easier for us to read because all that information is extraneous. It's not going to make a huge difference if it's 18.36192 degrees versus 18.36193 degrees. And on top of that, uh, there's not even really going to necessarily be that much granularity in in the way that the sense hat's reading it. It could just be, you know, it might not even be able to tell the difference between those two temperatures. It's just recording two separate ones, and there's small, sort of bits of fuzzy math that get translated into a slightly different value. It might, but not for our purposes. So we're going to say if temperature is, oops, I should actually use the correct. So if temperature is greater than 18.3 and temperature is less than 26.7, as it says right here, so we want to make sure that we're in between those two ranges, then we're going to say that the background is equal to 0, 100, 0. And that's going to be a nice green color. That's not going to be just like eye-meltingly green like we've set up in the past before, because remember the maximum value for RGB is 255. So if we set this to be 255, that would be super duper green, but it might actually be green enough that it would be hard for us to actually read what's on the sense hat. So we're going to dial it back a little bit and make it 100 so that it's still green. We get the idea, but we can read what's actually in the foreground much more easily. Else, if it's not in those ranges, we're going to say the background is going to be 100, 0, and 0, which is going to make it red. Again, not so red that we can't actually read the foreground values. Now, this kind of thing is debatable. You might be saying, hey, we want to just get the message across. Is there a way to reset the temperature? You should be able to sense clear. It should just constantly be reading the temperature with this um, program. Every time the sense gets temperature, it should be resetting the temperature value that's stored inside of the sense hat. It should be reading that thermometer, I should say. Is it giving you some absurd value? Hmm. What kind of temperature is it giving you? Ooh. Uh, that doesn't really work out well in Fahrenheit or Celsius. Do you have the sense hat next to like a computer or something? It might be reading the temperature of the computer because that is pretty close to an operating temperature for a computer. Well, uh, not inside, but close to the case if the computer's working particularly hard. The computer is, or the sense hat is. Okay, the sense hat's on the wall. I don't know. I guess it depends on the environment around it. It might be picking up that computer heat, but I don't know how close the computer is to the sense hat. Otherwise, it might be giving you, oh, and it's 80 degrees. Um, hmm, that's interesting because the Pi doesn't run that hot. 5 inches. Is it above the computer? Maybe it's the computer. Maybe you're getting a Fahrenheit readout. Um, but that wouldn't necessarily make any sense unless it was coded to be that way. And that's a very hot computer if it's still reading, even if it's reading 94 degrees Fahrenheit from 5 inches away. It might just be, it might just be the sense hat is just reading incorrectly. Unfortunately, I don't know a quick fix for that. Well, hopefully, the barometer and the accelerometer in it will be operating properly. But we'll get a sense, no pun intended, actually, of how cooperative it's going to be when we move on to these other topics as well. If it's still giving you a hard time, then your computer's 65 degrees. Is it giving you Celsius? It's probably giving you Celsius, which is about, really, it's running 65 degrees Fahrenheit? Huh. Wow, that's a really good cooling system. Okay. Um, yeah, that's uh, that's cooler than the inside of my house right now. Is it on? That's a kind of a dumb question to me to ask, but that's amazing. Yeah, yeah. Well, oh, there you go. Huh. All right, fair enough. You just have a much better airflow and cooling system than I do. Okay. I don't know then. It might just be that the temperature sensor is busted on the SenseHat, unfortunately. And I don't know off the top of my head an easy way to reset the temperature sensor, but I can look into that tonight. All right, so we've got our if-else statement. Obviously, you can modify these values if your SenseHat is reading odd temperatures, um, so that you can at least see the different values as they get read out. So we've got that, and then we'll roll it into our message. So, well, actually, first we'll create our message variable. So message is equal to temperature equals 0, pressure equals 1, humidity equals 2. And then after the, oh wait, that's a dot. Okay, so formats, temperature, pressure, and humidity. So, okay, what exactly is going on here? Well, these are little tags, and these are actually kind of a holdover from C. Sort of, kind of, it's the same basic idea. But these are little tags that are letting the program know, hey, we're going to stick variable values in here. And that's in fact what we do here. When we do the format, we do TP and H. And the only reason it knows which ones go into which one is just because of the order. We're going to stick T into the first open spot, P into the second open spot, and humidity into the third open spot. And so we've just formatted the string, this string literal here, to line up with the order that we place the variables in. And that's really all that's happening there, is it just knows to stick these values into the appropriate open spots. So that's composing our message. So the message is always going to be filled with the temperature, and then with temperature, and then the temperature pressure, and then the pressure. It is a dot. This is a period right here. Yeah. Yeah, those can be a little tricky to see even when zoomed in. So then finally, we're going to show the message on the SenseHat and get that all through there. So we're going to say sense.show message, and it's going to be our message, and we're going to say the scroll speed of the message is going to be 0.05 so that we can read it easily. And the background color, or back color, is going to be equal to BG, because BG is the background color that we set up here. So sense.showMessage, we're going to feed into it the message that we built, MSG, the scroll speed, which will control how quickly it scrolls, obviously, and the back color, which will determine the background color. And that's just going to be filled with the background value. And as soon as our temperature comes out of one of these acceptable ranges, background will switch from green to red. So if we were to run this, there's our SenseHat. Hey, temperature. Even it's still even a little bit harder to read, just like with the background. It's 20.1. Pressure, I had a hard time reading that, equals 1013. And humidity is equal to 44.3. So it's not 100% accurate. But the nice thing about this emulator is, too, I can affect the value. So as soon as the temperature climbs up to 29 degrees Celsius, which is starting to be around 85-ish, it turns red. Oh, yep, there you go. Here, let me actually expand this a little bit so you can see the whole thing. So now the background is red, and ironically, it's a little bit easier to actually read it on the red background than it is on the green background. So we'll move it back to, not negative 32. We'll move it down to 21 degrees. And as soon as it runs through its cycle, it should turn back to green. Eventually. And boom, there it is, green. Sorry, forgot to mute. I'll try not to assault you with the sounds of me um, consuming a drink. So raise your hand if you've got something like this running through your code or through your sense hat. Okay, we got a couple of hands. Is yours red because of the thermometer? Yeah. Well, like I said, you can screw with the values in here so that you can make it green. But the thing is, it says true. Oh, capital T in true, and that should fix that issue. All right, we'll wait for a couple more hands before we move on. A few more hands before we move on. They are curly brackets. They're not supposed to be parentheses. They are curly brackets. It says type method doesn't define round method. Uh, okay, so on you see my 9, 10, and 11 here that have TP and H that are all equal to rounds. Copy paste those lines into the question box. Okay, so that looks good. Oh yeah, that's true. You could do a scroll speed of 0.1. 32.8 Celsius is pretty warm. Hey, Luke. Could you paste those 3 lines of code into the question box? Yeah, I can imagine. You don't know where the code is, or where the lines I'm referring to are. Oh, the question box. Oh, okay. I'm tracking now. Just took me a minute. Um, would you be able to just type it exactly as you have it on the Raspberry Pi? Because the question box is what you're typing into right now in order to talk to me. I think it's called the chat box on your guys' end, maybe? Or it's the chat box, but you can tag it as a question. Okay, it is labeled as the question box. All right. Question slash chat box. All right. 75. Oh, gotcha. But IRL. Do the spaces and indentation matter? Yes. Python is a very white space dependent language. So anything that's a part of this while true loop gets indented to show that it's a part of this while true loop. One tab. You can just hit tab once and it's good enough. Or you can use 4 spaces on your keyboard. Notice how I've got an if statement that's also indented because it's a part of this while true statement. Anything that should be executed by the if statement is indented 1 level further. So this is indented 2 levels because it's a part of an if statement, which is a part of this while true loop. So 2 tabs or 8 spaces. So yes, it is super important how things are indented in Python, but I'm glad you asked that. Now the spaces between the lines, that doesn't matter. I can do this, and the code runs just fine. It's a little bit harder to read though, which is why I opt not to do that. This allows us to separate it into chunks that I can sort of mentally, categorize. Um, okay, gotcha. You forgot. Okay, well, hey, at least you got it, and you figured it out on your own. All right, how's everybody looking? Show of hands if you've got it to run. Okay, well, why don't I copy and paste this code into the chat box so that you can review your code against mine if it's not running properly, and then I'll start talking about the accelerometer and the sense head because that's where things also are pretty neat. right, and I'll just put everybody's hands down. Nice. All right, so the Sense Hat has a set of sensors that can detect movement. Yeah. It has an IMU, which is an inertial measurement unit chip, which includes a gyroscope for detecting which way is up for the board, an accelerometer for detecting movement, and a magnetometer for detecting magnetic fields. Magnetometer. Um, so before we start messing around with motion sensing, we'll talk about there are three key terms. I believe that. Yep. Okay. So this is just a quick 20-second video, real quick. These are the three axes that the IMU measures. So you've got pitch, yaw, and roll. Pitch, as you can see here, this plane is tilting upwards. That's on the pitch axis. So the plane will tilt upwards and downwards. Oh, well, it won't actually. Hold on. Upwards, that's pitch. This is roll. And then this is yaw. Pitch, roll, and yaw. There we go. So, I mean, it's pretty straightforward. So, yeah, pitch is like the plane taking off, or like the plane coming in for a landing. Roll is the plane doing a victory roll, an aileron roll. And yaw is the plane's nose tilt or steering left and right like a car. Um, so those are the three axes that we have on this. Is it super relevant to what we're talking about? Because again, like that, it's just if it's something you can throw into the question box, that tends to be easier as well, because then you can do it while we're talking about this stuff, and then I can. Okay. Yeah, pitch. Well, pitch and roll make a plane turn. Yeah, you don't necessarily need to shake your pie. Well, you can use a combination of the three in order to turn. But if you've watched like an airplane flying, a lot of times it will roll and then it will pitch upwards into that roll. So let's see here. A plane. Let's see, plane turn. And then you can use a little bit of yaw as well in order to turn into the turn more. But okay, so this is from the perspective of a plane wing, which isn't ideal. Let me see here. Let's do like the Blue Angels or something like that. Yeah, you can yaw for small adjustments, and it also sort of increases the turning radius or decreases the turning radius just a little bit more sometimes. But primarily, you'd be rolling and then pitching. Blue Angels are pretty cool, by the way. I don't know if you've ever seen any of the stuff that they do. This is them doing a loop. Yeah, this is pitch. But see, now he's rolling, and then they're still okay. So they went into what looks like an aileron roll there. So they rolled in order to reorient themselves. But now he's going to keep rolling and pitch up a little bit more. And it would, okay, so it's not exactly the best example, but he does do a little bit of course correction by pitching, by rolling and then pitching. And then they go up into another loop. But we can find out the orientation of the sense hat by using the sense.getOrientation method. So orientation is equal to sense.getOrientation. And then what that'll do is that'll give us an array. Well, a dictionary, technically. And the dictionary, we can get a value by referencing the name of that value. So think of it like a sort of like a bundle of variables. So if we wanted to get the pitch, we would call the pitch part of the orientation results, which is what we got here in sense.getOrientation. So we'll pull the pitch result out of the orientation results. We can pull the roll result out of the orientation result, and we can pull the yaw result out of the orientation result and feed them into their own respective variables. So this would get the three orientation values measured in degrees and store them as the three variables pitch, roll, and yaw. And you can explore these values with a simple program, which is here. Okay. So I'm going to go ahead and get rid of most of my program here. We're going to keep the while true because it is going to be another while true loop. All right, so while true, orientation is equal to sense.getOrientation. Like so. Let's stop this so that it can start pulling the stuff we're looking for again. Sense.getOrientation. Let's make sure. Hello. There we go. Orientation. Boom. And then we can do pitch, roll, and yaw are going to be pulled from these individual ones. So pitch is equal to tation, and then in square brackets, so you can see square brackets, pitch is in single quotes, so it's inside single quotes, which are inside of square brackets. Roll is going to be orientation, roll, same deal, inside single quotes, inside square brackets. And then yaw is orientation, yaw. So now we've got pitch, roll, and yaw in our sense hat get orientation. And what we're going to do is we're going to print those values out on the sense hat. So, well, actually, we're going to print those out straight to the console. I think there is a console here. Yeah, there is. Okay. So print, oops, pitch equals curly brackets 0. We'll get there. Actually, I believe the later slides start talking about the joystick. I believe. If not, we can cover that at the end of this presentation, and once we get through all the slides and everything like that, and talk about getting the joystick. So pitch equals 0, roll equals curly bracket 1, and yaw equals curly bracket 2. And we're gonna dot format that just like we did before. Format and then pitch, roll, yaw. And that is our whole program right now. So if we're to run this, as you can see, there it is. So we get a nice console down here, which provides us with updated values that the sense hat is printing out. And as I roll the sense hat around in the emulator, it gives me different pitch, roll, and yaw values. So as you can see, pitch and roll are 0, and yaw changes. But if I move upwards, we'll see that the roll value should only be changing, but this is not a 100% smooth thing. I can change the pitch value by tilting the front of it up and down, though. And yeah, so this will just constantly be printing out different values to the console so that we can watch the Raspberry Pi update with the different Sensat accelerometer values and magnetometer. And I've forgotten what the last one is. How have I already forgotten? Gyroscope. Good Lord, the simplest one. So another way that you can detect orientation is to use the sense.getAccelerometer_raw method, which tells you the amount of g-force acting on each axis. If any axis has plus or minus 1g, then you know that the axis is pointing downwards. What? In this example, the amount of gravitational acceleration for each axis, x, y, and z, is extracted and then rounded to the nearest whole number. Okay, so if it's minus 1g, then one part of that is pointing downwards. Okay. So we could do a similar thing here, where we could get the accelerometer raw. So I'm going to stop this real quick. You don't have to do this particular program. I'm just going to do it as an example so that you guys know exactly what they mean here. So we can do sense.get, because I know it's pretty close to 8 o'clock. Accelerometer raw. We'll call it acceleration. And this is x, y, and z. So x, y, and z. Acceleration. X, acceleration, y, and acceleration, z, and x, y, z, and x, y, z. So now if we're to run this and watch our values here, as you can see, they're kind of flipping out, but as I change them, we sort of get readable values. Let's round these. Okay, so x equals round x 0. Copy paste and change this as necessary. Y 0, Z 0, Z, Z, Y. Boom. Rerun it. There we go. See, now we've got -1 and 1, so we know that it's pointing downwards on the pitch. And if we roll it a little bit, we can see that the X is pointing as well as the Z. And we can get an idea of which direction it's pointing in as well. See, -Z, it's rolling clockwise. Positive Z, it's rolling counterclockwise. I only put it in those terms because I can't do a full 360-degree roll or pitch. If I pitch it downwards, the y-axis gets -1. If I pitch it upwards, the y-axis also gets -1. That's not right. Okay, so it's picky. So why do you think you get these values? Okay. Because you feel like you would get, if we rolled it, you should see changes in the y, but instead we see changes in the z. So why do you think that is? I'll give you a second to think about it while I get the poll questions started. Go ahead and answer them, and then once you're done, we'll leave it open for question and answer time. And also, if you have an idea about why that is, if you know you don't have any questions, you've got other things you got to do, you're more than welcome to head out, and have a wonderful weekend. Um, you're by no means obligated to stay here after the poll questions are over, but I just want to leave that open. But yeah, so let's go ahead and do that, and then we'll break for the weekend.